Hi everyone. Today we're going to talk about circumference of a sector. So if you recall, yesterday we talked about finding the circumference of the circle, so the entire edge around the circle. Today we're just going to talk about finding the circumference of just a tiny piece of the circle. And we talk about it as like almost a pizza slice. So think about a big pizza pie and like taking that pizza and cutting up into little pieces. The little pieces that make up the circle or the pie, those are called sectors. So obviously, the more slices you make, the smaller your pieces or sectors become. So in order to do that, we have to first figure out, well, how are we going to find the arc length of a sector? And then actually add in how to find the perimeter of a sector. Because if you think about a piece of pizza, it has an arc, but then it also has two straight sides as well. So before we actually get into that, we have to actually discuss. Ooh, I don't know how this is changing colors. Interesting. We have to talk about two kind of key vocabulary terms, and those vocabulary terms are called minor arcs and major arcs. So I want you to think about this. Here I have a circle, right? I have my circle O, and along circle O's edge we have X and Y. Now, if you take a look at what I did here, I just made this up, that arc here from X to Y is 150 degrees. And I was able to then determine that this arc from X to Y going in this direction is 210 degrees. Now I know this because in a circle, the amount going around the circle in terms of degrees must always be 360 degrees, right? That's the key number for circles, 360. So here's the thing. If I said, give me the length of arc XY, you'd be like, well, there's two answers, 150 and 210. But if I said, give me the length of minor arc XY, I'm hoping when I say minor, you think the smaller number, which is correct. So if I said, give me the length of major arc XY, you would give me the larger of the two numbers. Okay, so minor and major refer to the arc, minor being the smaller arc measurement, major being the larger arc measurement. Just so if you like look over here, there is some notation that happens. When we talk about an arc, we can write arc, A-R-C, or we can take the two letters that make up the arc and put a little arc right above those letters. So if you see this symbol over here, this can be read as arc XY. All right, so take a look at what we have here, kind of an example. It says if minor arc BC equals 140, so 140 degrees, BC, the minor arc, and I know to put that here also because this looks like it's smaller. What is the value of major arc BC? So do some simple math. 360 minus 140 is 220 degrees. So major arc BC equals 220 degrees. Now, look at this. Another way to get around using minor and major is actually by creating an additional point. So if I wanted to identify this arc over here for someone, right, the major arc, instead of saying major arc BDC, what I am allowed to do is actually insert my own point and label it DX, anything you want, and write arc BDC. So like angles with arcs, we follow the letter orientation. So if it's BDC, I go from B to D to C. Okay. So two kind of new terms, minor and major arc, along with throwing in an additional point if you want to get around actually using major or minor. Okay, so now that this is all cleared up, let's talk about how to find the circumference of a sector. So here's an example. You're given a piece of a circle, O, or a sector, and you're told that this angle here is 90 degrees, and you're also told that this radius, OR, is 12 centimeters. We want to find the length of arc, RP. All right, so what do we know? Well, we know that the radius is 12 centimeters, and we know we have a piece of the circle. We have 90 degrees of the full 360, right? So we have a piece of a circle, 90 of 360. We also know that since we're talking about the arc, that's circumference. And circumference is 2 pi r. And I'm using 2 pi r because I have the radius here. So let's think about this. All right, well, if the full circle is 2 pi r and r radius is 12, then I can handle that. I know that the full circle circumference is 2 pi r, so 2 pi 12. But I don't have a full circle. I have 90 degrees of my full circle. So look what we did. So what does this represent? This actually represents now the length of arc RP, right? This is the portion of my sector. It's 90 degrees of my full 360. And yet I'm taking it of my full circumference, which is 2 pi r. So that's how we kind of put it together for for circumference of a sector. We do the amount out of 360 times the circumference formula, which is 2 pi r here. And then we can just simplify. So 90 over 360 simplifies down to 1/4. And you can use that alpha y equals in your calculator, and it automatically simplifies that fraction down. And then I multiply 2 times 12 to give me 24. I leave my pi. And now I added in terms of pi, so I'm going to do 24 times 1/4 to give me 6. And remember, bring pi down. In terms of pi means leave pi out of the calculator, but it must be in your answer. Okay? So we get here that arc RP is 6 pi centimeters. All right. Now, same diagram, tad different. Now this wants us to find the perimeter of sector ROP. So we're told the same information. We know that it's 90 degrees of 360, and we know the radius is 12. So now think about what we're missing. Well, if I want to go the full perimeter, that means I need to go around this arc, which I know how to do that. We already found that arc length using this formula above. It's 90 over 360 times 2 pi 12. And then I actually have to go from P to O and O to R. Now I know these distances are the same because they're both from the center to the outer piece of the circle, which represents the radii. So 12 and 12. So yeah, 12 and 12. And again, if I'm going to leave my answer in terms of pi, I go ahead and I do 12 plus 12 is 24, and then I have 6 pi. Grammar of math says that anything dealing with pi should always go last. So I can't combine these terms because they're not the same. This 24 doesn't have a pi with it. So what I'm going to do is I'm just going to rewrite this as 24 plus 6 pi. This is how you leave your answer in terms of pi. This is not equivalent to 30 pi. 30 pi and 24 plus 6 pi have two completely different outcomes, okay? So this is going to be our answer here. So basically, what does this then tell us? Well, we should come away with two kind of ideas or formulas. First is the arc length of a sector, and that's going to be your theta over 360. So the angle of the sector times 2 pi r, or the angle theta of the sector over 360 times pi d. Remember, this is just your circumference formula. So either 2 pi r or pi d times theta over 360. The only difference when you have to find the perimeter of that sector, so it's like the arc plus the two straight pieces, which are the radii. So it's, again, theta over 360 times 2 pi r plus the radius plus the other radius, or theta over 360 times pi d, and then you add together your two radii. All right, so let's use these two concepts and answer a few questions. Okay, so first question is, the diagram below shows a circle. We have two radii. The measure of angle AOB is 120, and the length of the radius is 6 inches. We have to find the length of arc AB in inches. And it says, which expression represents the length of arc AB? So because they gave me 120 as my angle, I'm going to use that for theta, and they gave me a radius of 6. So I'm going to use that for r. Now, if you look at your answers, they all have pi, or most of them have pi in your answers. So what I'm going to do is I'm going to first substitute in everything, and then not evaluate until the very end. I'm just going to go piece by piece. So I plug in 120 in for theta. I plug in my radius as 6. 120 over 360 reduces down to 1/3, and then 2 times 6 is 12. I keep in mind it's a multiple choice question, and I have 1/3 times 12 pi, and that's actually choice 4. So there is our first example. Okay. Number 2, now you're going to be submitting this question on the Google form, but I'm going to just kind of give you some hints here. This is a circle is drawn to represent a pizza with a 12-inch diameter. The circle is cut into 8 congruent pieces. What is the length of the outer edge of any one piece of the circle? And then you'll be submitting your answer using the Google Forms. So for this, think about it. You have a pizza and you cut it into 8 slices. So I went ahead and I drew in 4 diameters to create 8 slices. I need to find the length of the arc of one slice. Well, okay, so what do I know? The diameter is 12, all right. And so if the diameter is 12, then I know that the radius is 6, right? So I know the diameter is 12, but that means that the radius is 6, okay? And there are 8 equal slices. So that means altogether it has to equal 360, but there's 8 equal slices, so I can do 360 divided by 8 to give me 45. So the 2 things I know. Theta is 45, that angle is 45, and the diameter is 12. Okay, so 2 key pieces of information. See if you can figure out the rest and submit your answer on that Google form. Okay, number 3, another question where it says that we have the path of a cart traveling on a circular track, has a radius of 2.4 meters, and then the cart starts at point A and stops at point B, going in a counterclockwise direction. There it is. So we're trying to find the length of minor arc, so they use minor, AB, to which the cart traveled to the nearest tenth of a meter. So again, I kind of just list what I know. I know that my angle, or my theta, is 165 degrees, and I know that my radius is 2.4 meters. So, based on the fact that I have the radius, I'm going to use 2 pi r, and then my theta over 360, and then I just substitute and plug in and round to the nearest tenth. So theta, which is 165 over 360 times 2 times pi times my radius at 2.4. Now, every single thing that you see here can go right into your calculator. You can do it piece by piece. You can use alpha y equals with each set of parentheses, but everything including pi goes in your calculator because you're rounding to the nearest tenth. And once we do that, we get that arc AB is approximately 6.9 meters. All right. And then we have number 4, and it says given circle O below with a radius of 9 centimeters and a central angle QOR. So that just means that the angle at QOR is 30 degrees. We have to find the length around minor sector QOR to nearest hundredth of a centimeter. So we're finding the length around the sector. It means that we're going from O to Q, Q to R, and R to O. So O to Q and O to R are your radii. So each radius is 9. We'll get that taken care of first because that's nice and easy. And now the arc from Q to R, well, we know the radius is 9, and we know theta is 30. So we have 30 over 360 times 2 pi 9. And that all simplifies down to 3 over 2 pi. Or you could just plug everything into your calculator, round to nearest hundredth, so that 2 tells the 1 to stay. And the length around minor sector QOR is 22.71 centimeters. All right, so this sums up circumference of a sector. Remember, when we're dealing with the sector, it's a piece of a circle. A full circle is represented by 360. We say the piece is the theta over 360. We're dealing with circumference, so it's either 2 pi r or pi d. Just make sure that you go back and you go ahead and answer number 2. I gave you a nice hint here by using your Google Forms. And tomorrow we will be getting into area.